Welcome, everyone. This session is cross-site port scanning. Our presenter today is Riaz Walikar. Riaz is from Bangalore, India, and is a web application security engineer, pen tester, and network security architect for food, shelter, fun, and passion. He has found vulnerabilities in popular web applications like Facebook, Twitter, Google, Cisco, Symantec, Mozilla, PayPal, eBay, Apogee, etc., for which he is on the Hall of Fame for most of these services. Please join me in welcoming Riaz.
Good evening. The presentation is titled Cross-Site Port Scanning, but then when I submitted the paper to OWASP for the CFP, after that I have managed to find a lot of other things that you can do using this vulnerability. It's not limited to port scanning. So I went ahead and modified it to, I generalized the term using poking servers with Facebook because that's what the vulnerability was where I found it the first time. I managed to find it in a bunch of applications, so the final presentation title would be poking servers with Facebook, Google, Mozilla, Adobe, and yet the Yahoo Developer Network. Right, so basic introductions there. I'm a web AppSec consultant for PwC SCC back in India. I'm a pen tester. I do a lot of bug bounty hunting as well. I'm also the null security chapter lead for Bangalore. Null is India's largest open source community, and I happen to be the moderator for the Bangalore chapter. Right, so before I actually land on to the vulnerability itself, I'm going to be talking about how I managed to find the first one. And this is kind of a storytelling for me. So I started hunting for bugs on several bug bounty programs last May, and mostly for the money, and obviously the Hall of Fames. Who wouldn't want to be up with Mona Lisa and Thor? Right, so the first bug that I found with Facebook allowed me to, kind of the URL would allow me to fetch a page that I had control to. Now, it was a user-supplied URL. And the page would pull, the application would pull the title tag from the URL and display it to the user. So the page was send button from shell.php. Facebook's already fixed this several months ago. But the node URL parameter was, users could supply their own URLs there. When I give google.com, it fetches the title and the icon as well as some text from the page and displays that here. So what I do? I tested this page for XSS, SQLi, LFI, SQL injection, LFI, RFI, like most other application testers would. Finally, I wanted to see what was the request that Facebook was sending, because it's going to be fetching the server, fetching a page from the remote server. So I wanted to see what was the HTTP request that it was sending, see if any headers are unique to Facebook servers. So I set up a HTTP server with port 8080 exposed to the internet. And this was a stroke of luck that I mistyped the URL after setting up the page. I did my server :808 instead of 8080. And I noticed that Facebook gave a distinct verbose error for a closed port because 808 was closed on my system. Facebook gave me a unique error for the closed port. I tested again with open ports as well as closed ports. I tested with non-HTTP protocols like 22, 23. Then I tested with HTTP-based protocols as well. And I found that Facebook returned a different kind of error for several different categories of ports that I would test it for. And what did I realize? I realized I could port scan the internet. I could port scan internet servers using this vulnerability based on the distinct errors that Facebook gave me. What is the underlying issue with Facebook? Facebook is using underlying server-side code to create socket connections to remote servers to download content. This is technically not the issue. Generally, how Facebook is doing things at their end. The primary issue was that Facebook gave distinct errors on closed ports as well as open ports, which is what led me to build the port scanner that I'll be talking about. There was also no proper data handling for non-HTTP streams. For example, Facebook is expecting, or rather, Facebook expecting an HTTP page to come back. When you say http:/google.com, Facebook is expecting HTML page response to come back. But then when you specify port 22 or port 3306, it's on HTTP. So what did I do? I sent a mail to Facebook describing the issue. Facebook said it's not an issue. They didn't see how this was a problem. So I sent Facebook a proof of concept Python port scanner that I wrote using Python. I also managed to scan a couple of internet servers, mostly Microsoft, knowing that Facebook and Microsoft are pretty close to each other. I scanned some random servers on the internet. Facebook replied and acknowledged that this was an issue. There you go. So this was the first bug that I found, with all the bug bounties that I've done. I was listed on the Hall of Fame as well as one of the first, in fact, I was one of the first Indians to be awarded the white hat debit card as well. Then a bunch of other places that I found this vulnerability, and later on when I found that you could not only limit this vulnerability to port scanning servers, but you could also do a lot of other attacks on the internet. I generalized this whole vulnerability as cross-site port attacks. So when does it occur? Cross-site port attacks occur when a web application attempts to connect to user-supplied URLs and does not validate backend responses. And this is important because most of the application vulnerabilities that we've seen till date, SQL injection, cross-site scripting, all the other top 10, most of them can be thwarted using input validation, right? But then how do you control, because HTTP:/server IP:22 is a perfectly valid HTTP URL. The HTTP RSC allows you to insert port numbers into the URL. So validating backend responses, or technically validating the output response that you're going to send to the client is important here. XSP allows an attacker to port scan servers, attack services. We'll see a demo of this, internet-facing as well as internal devices, while proxying the attack from another web application. So if Facebook has this vulnerability, I can port scan Microsoft or Google's IP addresses using Facebook's IP address. Right? So I'm technically proxying the whole attack from there. Let's take an example. For example, if there is an application which is expected to fetch an XML file from a remote server. So when you say remote_server.com XML file.xml, the server status and body response that you receive is a 200 OK, and the XML file is actually retrieved. When you specify :22, now obviously there's no HTTP service running on :22. It says the server status is 200 OK, but it says invalid XML data. When you say :3306, it says invalid XML data. And when you say 8081, it says connection refused. So based on this, what ports are open and what ports are closed? Anybody? So on remoteserver.com, what port is open, what ports are open, and what port is closed? You know for sure that 80 is open. What other ports are open? Right, so 22 and 3306, the MySQL server port on 3306 is open. Because when you try to access 8081, the error message that you receive is connection refused, which is definitive. That you can try it out with other closed ports, random higher number ports like 40,000 odd. And you'll see that if there's a connection refused and if the error message is static with all the other closed ports, then you can be sure that you can use this URL to port scan. Three main issues. Application displays verbose errors for failed socket connections. Applications do not verify received data from the remote server if the connection is successful. So when you saw the port 22, the application managed to connect to port 22, and the file that was retrieved was not, it was not passed in proper XML format. But then the error message clearly said that XML data not received or whatever. So instead of that, or rather, even when you connect into a closed port, right, if the connection is successful or not, you need to provide a generic error. And applications do not blacklist internal IP addresses. There are a bunch of examples that I have later on. Actually, I was going to do a video demo as well, but then it looks like that won't work. When I've noticed that applications can, instead of specifying an external IP address, what would happen if you specify 127.0.0.1? Right, you're technically port scanning local host. Although through the firewall you may have patted the port. You could host an application on 8080 and forward it through port 80 on the internet. But then when you scan local host ports, you should be able to see that. So why does it work? For example, consider a normal internet scenario where you have firewall port 80 open, 10.05, and you have a web server with 1.05. Now, web servers behind the firewall have the ability to connect outside, right? So to pull data, to pull files, to update itself, whatever. But then web server 1.05 is able to connect to a remote server as well as internal machines, right? So if the vulnerable application is running on 1.05, you should be able to attack other services as well. How many of you are PHP developers here? PHP, some amount of PHP. Nobody? Nobody's from a developer background. Okay, there's nothing wrong with the code. Most developers program it this way, but then what they're missing is one essential piece of code, piece of line there that verifies and tells you that if there is a connection, because the file get contents, the function file get contents is a valid PHP function, which is used to retrieve files from remote servers. But then when a connection is made when a low-level network level socket connection is made, the error message that PHP prints should not be, should have error handling here that prevents the function itself from not displaying what it received from the lower sockets, lower networks, low layers of the network. Similarly, the case with fsoc open, which takes in multiple arguments, the same issue. If you specify a generic error for closed ports as well as for open ports when you have not received the file that you wanted to receive. For example, if you're fetching XML files or text files, and if you have received garbage, what happens when you connect to arbitrary ports. Ensure that you have a distinctive generic error message that says that ports closed. It's hard to hear. Okay, sorry. So I'll do a demo. Okay. I have an application which accepts file. I'm not connected to the internet, but then what this application does is if I type the name of the path of a text file on the internet, it will fetch the text file and display it to me here. Okay. So instead of fetching text files, what would happen if I I'm just checking if it will connect internally to port 8080. Okay, what do you see here? It fetches whatever data is received from as a default file for port 8080, which is the JBoss. There's a JBoss server running on the same system, but obviously it's not accessible outside. The point here I'm trying to make is that most application sysadmins as well as application developers do not program applications that are running on internal networks securely. Right? That's true in most companies. You would have secure applications. You'd fund all your research. You'd fund all your security programs into securing applications that are exposed to the internet. But internal applications, your HR applications, the finance applications, are not always tested for security. So if there is a way to attack applications that are running on the internal network, this is it. You should be able to access internal applications, internal services running on the remote server. Right. So if I attempt to access maybe a random closed port. So I say it's a okay. I'm using tamper data here. Everybody is familiar with tamper data? Tamper data is a Firefox add-on that allows you to trap requests that are going out from your browser. You can then edit your requests and then mostly post requests. And edit your requests and then send them out. Most pen testers, web application security consultants use this to bypass client-side JavaScript protections. Okay. It did not give me any response. Let me try accessing. Okay. I'm going to try and generalize this based on what error messages are received. There's no error message here, but what can you see? That in all the cases wherein you had a port closed on the remote server, the size, the response packet size, the HTTP response size that was received is always 303. Okay, that's 303 bytes that have been received from the server. So there are multiple ways of looking at it, not only as descriptive error messages. You could look at time-based functions as well. You try to connect to an open port, the application takes a lot of time. You try to connect to a closed port, the application immediately displays some text or the other. So based on this as well, through inference, you should be able to do a port scan. Right, so we saw 8080 is open, we saw 303, we saw a bunch of other ports that are closed. So because we have now a distinctive way to identify closed ports and open ports based on either the size of the packet that is coming in and error message and other things, we can script this. Is it visible behind? Okay. Right, so I ensure here that if the length of the data that is received is 303, then the port is closed. Otherwise, I can print the data that is received and I'll mark it as open. So if I run this, okay, it's a custom Python script that I've written. I'm scanning for ports 21, 22, 3389, 3306, 8987, 8080, 8081, 9090. Okay? It says 21 closed, 22 closed, 3306 open. Okay, it's found a bunch of data. It says 21 closed, 22 closed, 3389 closed. That's RDP is closed. And I see 3306 open. I mean, my SQL server is running on the same system. I also see an 8987 port open, which is some sort of network simple time server. It's some sort of server that prints the time on the server when you specify an input. Right? So let's see if that's vulnerable. I also printed a bunch of HTML, so I'm assuming this is from, yeah, it's from 8080. Right? We saw that there was a JBoss server running on the same system. There's 8081 and there's 9090 which are closed. I found this, I found XSPA in Facebook. This is just half of the whole setup that I found. A bunch of other places, Google, Adobe, Pinterest, Yahoo, the developer network, which is pretty nasty. The RPG consoles, Mozilla Foundation. For Mozilla, it was recently awarded the largest bug bounty that they have on their role. Okay, the vulnerability with Facebook was that when attempting to connect to an open port above 1024, it printed some text. Okay, now all I'm doing is HTML parsing. Okay, either you can do HTML parsing for the data received, you can look at time responses again, or you could look at the response packet size that has come back. So based on multiple things, unique behavior when you're trying to connect to a closed port or an open port. So application specific response for open port above 1024, I don't know why the behavior was with Facebook this way, but then when connecting to an open port above 1024, I had text. When connecting to a port below 1024, it said the page at whatever server could not be reached because the server returned status code 502. Although the status response that I received as HTTP was 200 OK. But in the backend, a 502 was received. For a closed port, it said server return status code 503. So based on these error messages, I could build a port scanner around this. I found this with Google as well. In their Google Webmasters is fixed again. When attempting to connect to, so for all my testing, when in the event that I was not able to set up a server of my own, I used scanme.nmap.org, which is a public nmap own server set up by FIDOR. Which has certain ports open, and FIDOR encourages you to use that if you're practicing Nmap. So it's public knowledge that port 22 and port 80 is open on that. So when attempting to connect to port 80, it says we couldn't find the verification meta tag. When connecting to port 22, it says your server returned an invalid response. When connecting to a closed port, it says we were unable to connect to your server. And so you have 3 distinct error messages. You can use that. Yeah, the Mozilla Marketplace also had this issue. This is based on response headers that I received. So for open port again, for open HTTP port, it said we saw text/HTML right here. And for open non-HTTP ports, it said it did not give me any MIME type. And for a closed port, it directly said network is unreachable. Okay, so I'm just going to skip that video. Right, so what? You could port scan. What else can you do? So that's what I said when I submitted the paper for OWASP AppSec. I was stuck at port scanning, which is why the title is port scanning, cross-site port scanning. But then I also realized, and I managed to set up a server wherein you could use this vulnerability to attack internal applications as well as attack internal services. Right, so what can you do? Because you have the ability to send GET requests to internal web applications, right? So you can, imagine there are a bunch of applications out there which people host on internal networks, which are vulnerable to URL-based attacks like SQL injection or parameter manipulation. There are a bunch of places where you have URL-based LFIs and RFIs possible, right? So you can attack all those internal applications once you've done fingerprinting on the web app using XSPA. Oh, because we also control the get/data part when you're trying to send a request. Let me quickly show that to you. I'll use tamper data. Because I can control what data I'm sending as part of the get request. Although from this application, I'm posting to this application, but in the backend, the application is sending the request out to localhost to fetch test.txt as a get request, right? Because I can control this part. I can control this part, right? I can insert any data I want here, and the application will, on my behalf, send the same request to the locally hosted application. Right, so, yeah. So what does that create for us? Because you can send the get/data part is controlled by the user. You could attack internally running applications, internally running programs as well. Imagine if there is a program on the same server or on the network which accepts data and is vulnerable to a stack-based buffer overflow. You send it a bunch of trash data and the application crashes. You have denial of service. But if you're able to control what you're sending, and if you're able to figure out what operating system, a bunch of other things, you can build a reliable exploit and send it out to the server as well. You could practically run code on the remote server. Okay. I'll do a demo of this because I have the exploit code ready for one of the applications. As I said, sending a bunch of garbage text to applications or internally hosted programs could crash the remote service. You're practically doing a denial of service for the internal network. I'll do a demo of. Okay. So as I said, earlier we saw that we found there was JBoss server running. Now JBoss, older versions have had this very peculiar, the default configuration did not have an administrative password, right? JMX consoles run on port 8080. And there was a primary flaw with the application installation was that there was no default password for the GMX console. You could merely connect to port 8080 and you were in, right? The default configuration said that. So if I try to figure out, if port 8080 is open, it says, yeah, this is a JBoss instance. There were two sets of vulnerabilities with JBoss. One was obviously there was no username and password requirement for you to log into the 8080 console, GMX console. The other was a very peculiar and much less exploited vulnerability with JBoss was that you could convert a post request as a one-liner get request and send data to JBoss. Okay, practically the implication of this was that people could do a CSRF attack. There was no token or anything that was going either through post or get. But then because you could convert, because it was handy for you to convert a post request to a get request and still it would process it, we can actually use that to attack the remote server. And okay. That visible? I'll increase the font a bit. Okay. This was a one-liner JBoss vulnerability that existed in a lot of installations on the internet. It's still now, if you use smart Google Doc, and you should be able to figure this out. The GMX console has an HTML adapter, multiple arguments, but then the primary and important argument for us is the arg0, which is the end. Now you can specify an external WAR file on this URL. The JBoss console would download the WAR file for you, deploy it without any, without you requiring to enter any credentials anywhere. So it's a one-liner attack code. You could merely upload a shell. But how do you attack this? This is inside. This is not exposed to the internet. Because XSPA allows you to access applications that are running locally, on the internal network and not exposed to the internet. Because it's sending GET requests. I control this. Right? So I have another server which is hosting a shell. So I'll quickly try and access and see. I may have done this already during testing. So shell/shell.jsp command equal to dir. It says file not found. But when I use this URL, okay. So what does it say now? It says operation completed successfully without a return value. That means our shell has been uploaded. How do you access the shell? There you go. So we have shell access to the server on which the JBoss console is running. What did we do? We attacked the JBoss installation using XSPA. Right? So using the from the internet, we looked at an application that had XSPA. Using the XSPA vulnerability, we managed to push a WAR file to an internally hosted JBoss system. And then we are using XSPA again to fetch details from the server. If this was not bad, there's something else here. This is a server that's running, that's hosting the JBoss console as well as this JBoss console, and the application on 8987, port 8987. Now, the application is vulnerable to a stack-based buffer overflow. It's readily available on the internet. I've broken down the code. I should give us. Okay. It's scary at the beginning when you look at it, but then the upper line before the white space, before the carriage return, is buffer data that we're sending. Okay, and the second line is actually the address of a register which is going to be put into EIP. Okay, and the last is the shell code. This will pop up calculator, right? So now because HTTP is a text-based protocol, I cannot send. I mean, I had shellcode that normally when you're doing exploitation over the network, you can send binary data, but because HTTP is text-based, you need to convert all your shellcode to pure text. Right? So finding a register whose address could be converted to ASCII equivalents was a little bit time consuming there, but then managed to pull this off. So if I push this data via the application, I'll run a tamper request on this. So I'm trying to access, or rather I'm trying to connect to port 8987. Okay. I'll generally say okay for now. Let's see what the response comes out. So it says network simple time server version 111. It says please enter your name. And what was the name? Normally, when you connect to this application, you enter your name and it says hello, whatever. The server time is whatever. But then if you see carefully, it said hello get/HTTP 1.1, which was being sent via the PHP web application. So this is happening at the backend. So because I control the get/data part, let's see if I can push shellcode to this. I'll have the VM running in the background so that we can see if calculator pops up. It should. I've tampered. Let's pull this down. I say submit. It's a tamper. That's because I control the /data part. I paste the shellcode here. There you go. So what have I done? Using XSPA, I have managed to run code on the local server. Right, so I don't have a backtrack VM, but then there's another piece of code that I had which would allow me to open a reverse shell back to my system because systems are allowed to connect outside the firewall. Right, so this is bad. So using XSPA, we were able to upload a shell to a JBoss installation as well as run code on the local server. So how do you fix this? The basic mitigation is to force applications to not fetch data apart from over servers that don't utilize port 80 and 443. But it's not always the case, because there are some applications that run on esoteric ports that are not 80 and 443. In such a case, if data from other ports is required to be fetched, make sure that the data can be passed in the format that the application is expecting it to. So if you're going to fetch an XML file, make sure that the XML file is what is coming back. Obviously, do not allow connections to private IP addresses. This is bad. Handle all errors. This should have been on top, but handle all errors and exceptions and timeouts that arise because the application was not able to connect to a service on the back end or whatever the reason is. Display generic error messages. So if you manage to connect to an open port and retrieve an XML file, if it can be passed, show the XML file. But if you manage to connect to an open port that is not HTTP based, and if you manage to obviously when you're trying to connect to a closed port, in both the cases, make sure that the error message is generic. Right? That's what Mozilla did with the fix for their marketplace. So initially, when I submitted this, the error message that they've put in place now tells that if I'm connected to an open port, but the data that is being retrieved is not in the proper format that they're expecting, they just say file in invalid format. And if I'm connecting to a closed port, they still say file in invalid format. So I'm not sure if the port is open or closed. So that's smart there. Bunch of references. I've almost come to the end of the talk. Bunch of references. The RFC protocol for the RFC for HTTP. Arsenic had done something similar, but then that was purely client side, wherein a server that you're connecting to could use CSS and JavaScript and port scan your internal network. Both those articles there. Special thanks to all these guys who managed to bunch of the program as well as the exploit code development. Yeah, the end. Yeah, see, ideally what you're trying to do using XSPA is you're using error messages in case of when you're doing port scan, using error messages that the application is returning to identify if the port is open or closed. Now, Mmap is too direct that way. Mmap does all this at the network level. You're doing this at the application level. So yeah, almost all of them are, except for 3 companies that are still pending. They don't realize how easy this is to exploit, as well as a bunch of other things. I haven't spent time on researching what else you can do once you have access to internal networks. But then it's pretty nasty, at least and I have tried utilizing this in the pen test that I do for my organization, as well as a bunch of other people from the community that I was talking about back in India. And most of them have come back to me and said that a lot of applications on the internet have this issue. And a couple of my friends who also do bug bounty have managed to find this with other applications as well, and get a bounty for that as well. This mostly comes out at during pen testing. For SAP applications, for example, there's a 0-day standing out there. One of the SAP URLs can be used to port scan internal systems. That's still not fixed. Cool. That guy's my hero. That's it. You can reach me at that's my blog, and I haven't blogged about this as yet. I'll be doing that once I get back to India. You can follow me on Twitter on Riaz Walikar. Thank you.